All right, today we're going to do section 12.4. We're still talking about rational expressions, and today we're going to be dividing rational expressions. We're going to start with monomials. And you're going to need to remember the rule for dividing fractions. For instance, if you have like 3/5 divided by 2/3, you know that the rule for fractions is you invert or flip the second number and multiply. So this becomes times 3/2 or 9/10. We're going to do the exact same thing with your rational expressions. So what I have to do this problem is I have to flip the second fraction and change it to multiplication. So I have 5x squared over 7 times 21 over 10x cubed. Now at this point you can either multiply straight across or you can cross reduce. I'm going to cross reduce here. So my 5 and my 10 reduce down to 1 and 2. My 21 and 7 reduce down to 3 and 1. Then I have an x squared and an x cubed, so I have an x on the bottom. So my final answer here is 3/2x. Now you try one. Go ahead and pause the video, do the problem, and then come back and see if you get the answer correct. All right, I'm going to flip the second fraction and change it to multiplication. And then I'm going to reduce before I multiply it just because I feel like it's easier. 6 and 24 reduces down to 1 and 4. 5 and 75 reduce down to 15 and 1, and then I have an x to the 4th and an x, so I have an x to the 3rd on the top. So I have 15 x to the 3rd over 4. That should be your answer. All right, now these are all monomials, so now we're going to switch to binomials and still continue with our division. So a binomial problem might look like this. Again, I have to flip the second fraction and multiply, so it becomes n plus 1 over n plus 3 times n plus 4 over 2n plus 2. But because I have binomials, now I need to look and see if I can factor anything out. This doesn't factor out, so that's still n plus 1. This doesn't change, that's n plus 3. That doesn't change, it's n plus 4. But down here, I can factor out a 2, so I have n plus 1. Now understand, these are all multiplied together. So remember our rule, once they're all multiplied, then you can reduce down by canceling the whole parenthesis out. So n plus 1 and n plus 1 go away, so you're left with n plus 4 over 2 times n plus 3. All right, now let me give you one to try. Go ahead and try that and then come back to the video. All right, I'm going to go ahead and bring this down and flip the second fraction and make it multiplication. Okay, the only thing I can factor out is that top one. I can factor out a 3, so I have m plus 4 over m plus 5 times m plus minus 2 over m plus 4. You see that the m plus 4 and the m plus 4 go away, so I'm left with 3 times m minus 2 over m plus 5. That should be your final answer. If you want, you could distribute that and make it 3m minus 6 over m plus 5. Either one of those answers is correct. All right, let's try another one. All right, this one's a little different because the second term isn't written as a fraction, but remember you can always make a problem into a fraction by placing it over top of 1. So that's what I'm going to do on these, and I'm still going to continue the same method. I'm going to flip the second fraction and multiply. And then I'm going to factor anything that can be factored. So I'm going to factor out the 5. Remember, I'd have to mark out the whole thing, which I can do right there, leaving me with 5 over a plus 5. All right, you try one of these. Go ahead and try it and then come back. All right, I'm going to bring everything down so that I can flip the second and multiply. Remember, that's the same as over top of 1, so it becomes 1 over x minus 3. I'm going to factor out the 12 there, so it's x minus 3 over x minus 7 times 1 over x minus 3. The x minus 3's go away. I'm left with 12 over x minus 7. All right, let's go on to a bigger problem. The factoring is going to get just a little bit more difficult here. Again, the first thing I'm going to do is flip the second fraction and multiply. So I have m squared plus 3m plus 2 over 4 times m plus 1 over m plus 2. I've got to factor that. Now that's a trinomial, so I know I'm going to put it into 2 sets of parentheses. So I have m, and I have 2 and 1, and that's really the only choice I have. And the only thing that cancels out is that. But notice on the top I have 2 of the same thing. I have an m plus 1 and an m plus 1. So I can write that as m plus 1 squared because there's 2 of them. And I have a 4 left on the bottom. All right, now you try one of these. Go ahead and work that out and then come back to the video. I'm going to bring this down. I'm going to flip this. Okay, now I have to factor this. So I have q minus 13 and q plus 2 is what that factors into, over 7 times q plus 7 over q minus 13. The q minus 13 goes away, and you can leave the top just factored out, just like that. If you want to, you could do FOIL there and have q squared plus 9q plus 14 over 7. Either that or that is an acceptable answer. All right, the last thing we're going to do in this section is something called dimensional analysis, and this is a little bit harder. This is just a touch of it, so do the best job you can on it. And basically dimensional analysis is converting using units. So let's say you have an orbiter that travels the Earth to Mars, and it travels at 466 million miles in 309 days. And we want to know the speed in miles per hour. So what I'm starting out with is I have that many miles in 309 days. Well, I know that when I finish, I still want miles, but I want the days to have been changed to hours. So what I'm going to do is I'm going to work on getting rid of my days. So if days are on the bottom, I need days to go on the top so that those two things cancel out. And let's say I want, on days, I want hours on the bottom because that's going to be my final thing to put on the bottom. So 1 day is equivalent to 24 hours. So in order to do this problem, I know I'm going to have to take the 466 million and divide it by the 24, and you can use your calculator for that. 62,837.11 miles per hour. And that would be my final answer. All right, let's do another one of those. This one involves your metric system, which you probably have done some of this in math. You know your metric system looks a little bit like this. Where you have the kilometer, the hectometer, the decameter, the meter, the decimeter, the centimeter, and the millimeter. These are all smaller than a meter. These are all bigger than a meter. And I've got 85 kilometers per hour that I want to change to meters per second. Okay, so I'm going to start out with the 85 kilometers over 1 hour. Now the hour is going to have to change to seconds. The kilometer is going to have to change to meters. So the first thing we're going to do is we're going to change the kilometers to meters. So if I'm right here, let's say I have 1, every time I move it to the right, I'm going to move the decimal 1 place. Okay, so I'm going to go from here to here to here. So I'm going to move the decimal 3 places. So what I know is that 1 kilometer is equal to 1,000 meters. Okay, so I've changed my kilometers to meters. Now I have to work on changing my hours to seconds. Well, you know I want to get rid of my hours, so the hours is going to have to go on the top. And the first thing I'm going to do is change it to minutes. So 1 hour is equal to 60 minutes. And then I want to get rid of the minutes, so I put that on the top, and I change it to seconds. 1 minute is equal to 60 seconds. So now what I'm going to do is I'm going to multiply the 85 times 1,000, and I'm going to divide that by the 60 times 60, or the 3,600. And again, you can use your calculator. And that's going to give me 23.6 meters per second. And you see that those are the units that you have left. These units, let's see, actually the meters stay, but then my hour goes away and my minute goes away. So you're left with meters per second. These are going to be a little bit harder. Just do the best job you can. This is like at the front end of being exposed to this, and then each year you'll get exposed to it a little bit more. Your homework is page 662 through 663, 14 through 36 even.